Hey guys, welcome to my YouTube channel. Today we'll be solving question number 55 jump game. So we are given an integers array nums and we are initially positioned at array's first index and each element in the array represents our maximum jump length at that position. We have to return true if we can reach the last index, otherwise we have to return false. So we can check from the first example that at this position we are at the first position, that is showing that index 1, that is showing that 2. So at max we can reach here. So here it shows that we can, that number represents our maximum jump length at that position. So that means that we don't need to go to all that to the last position. We can see that if we go to one, if we take only one jump, that is 3, we can go to 4, that is the last index. So that is why we can say that the output will be returning true. The other example we can see that 32104. So here we are at this first position and the max we can jump is 0. So since it is 0 we can't move anywhere else, so we should try to go to the, take only one jump, that is 2. So if we go to 2 only, that would be showing that we'll be going to the third position only, and similarly if we take only 2 jumps and come to the one index, we'll be reaching 0 only. So that's why it is returning false. I'm going to solve this question using two different approaches, that is DP and using Kadane's algorithm. First, we'll be using DP tabulation. So first, I'm going to solve it as int n equals to nums dot size, the nums dot size, and then we will be going vector of int, then it would be DP, and then it would be take n 1 minus 1, and then we will take a base case of dp n minus 1 equals to 1, which would be our base case. Then what we are going to do is we are going to loop through it for int idx, which would be n minus 2. Idx is greater than equals to 0, idx minus minus, and then we're going to, if nums of idx is equals to 0, we are going to do dp idx would be equals to false. Then we'll do keep it a continue. Then after that we can see that it would be int will create a flag position of 0, which will be showing as 0, and then we'll take another variable called reach, and it would be idx plus the nums of that idx that present is. Then we'll go for int jump equals to idx plus 1, jump is less than equals to reach, um, jump plus plus. Then what we do to do is, if jump is less than equals to nums dot size and dp is jump, then we are going to do is dp of idx equals to true, and then we are going to move the, give the position of flag 1 equals to flag equals to 1, and then we are going to break. Now after that we are going to check if flag equals to 1, then we are going to continue, and then we'll do is dp of idx will returning me the false. After that, we are going to do is return the TP of zeroth position. So, and then will be, so let's just check it. Hmm. So as you can see that it has accepted our solution and we are judging it, and solution this it is accepted. Now I am going to use another solution for this problem, and we are going to use Kaden's algorithm. So Kaden's algorithm tells it will shows that what index we can reach. Initially we can only reach index 0, hence our reach would be equals to 0. So what we are going to do is int reach equals to 0, then for int idx equals to 0, idx is less than equals to nums dot less than is nums dot size idx plus plus. Then what we are going to do is at every index we'll check if we can reach at least or able to reach at a particular index. If we can at least reach to a particular index, and we'll check if reach is greater than equals to idx. If it is, then we'll carry on with it. So if idx sorry if reach is less than of idx, then what we are going to do is return false. Okay, and then we are going to see if now we can reach to that index. It would be time for us to update our reach, as at every index we are getting a new jump length. So what we are going to do is reach equals to max of either reach or idx plus nums of idx, and then after that we are just going to return true if we can reach the last index of it. So this is much more easier option. Using Cadence algorithm, we can see that the time complexity would be order of n, and our space complexity would be 0 order of 1.